Hello and welcome to another episode from Spiral Physics Education. This time we're going to be looking at work done and power. We're going to look at defining power and its units. We're going to be referring to power in terms of work done and time taken, looking at some vocabulary that way. We're also going to be looking at some worked examples using some equations that we've met before, such as gravitational potential energy and kinetic energy store equations, along with work done being equal to the product of force and distance moved in the direction of that force. So you need to know a few things to get the most out of this lesson, and they're going to be examples of stores and transfers, that work is done when energy is transferred between different types of stores, and also the equation for, here we've got kinetic energy, half mv squared, and gravitational potential energy mgh, and also work done is force times distance moved in the direction of the force. Okay, so let's get the wordy bits out. So power, what is power? Well, power is defined as the rate of doing work, but for like most of the definitions that we have in physics, we can turn that definition into an equation. So this is the equation form of that definition. And we can work that out by looking at some of the different terms in that definition, such as rate of. Now, rate of always means that time taken is in the denominator and everything else in the definition is in the numerator. So work done as the numerator, but rate of means the denominator is always time taken. We measure power in watts, and that means that we can also say that 1 watt is 1 joule per second. And if we look carefully at the equation again, and we know that work done is measured in joules and time taken in seconds, we can see why power is measured in joules per second. But most of the time we don't say joules per second, we just refer to it as in the watt. So some vocabulary for you to get used to using some terms that you might be used to describe what's happening or explain what's happening in terms of power and work. So for example, let's say that we were looking at comparing something as being more powerful to something else, a device, a person, or an object. That means that they do more work in a certain given time. Or we can say that a person or object is more powerful, that they or it will do the same amount of work but in a much shorter period of time. And that means that they are more powerful. So you can refer to power or powerful in those terms, i.e. how much work they are doing in a specific amount of time. So let's have a look at some of the mathematical examples. So we're going to do 5 examples, always looking from different directions of how exam boards present their questions and expect you to be able to cope with concepts such as work and power. So in this one, we're going to just have a straightforward one where a kettle does 400 joules of electrical work in 0.2 of a second, and we're just going to calculate the power of the kettle. So remember that the first thing that you do is write down an equation. Need to substitute in at some point, but we're just going to check whether we need to rearrange it first, and we don't because we're calculating the power and the subject is the power, so we don't need to rearrange. So we can just go straight in and substitute in our values of 400 and 0.2, and we get an answer of 2000 watts. And we can also say that that's equal to 2 kilowatts. Okay, second example, same 2 kilowatt kettle, but it's going to be on for 3 minutes to boil some water. Let's say to make a cup of tea, which I'm absolutely gagging for right now. And we're going to calculate how much electrical work is done here. So we can go straight in with our equation. We're trying to work out the work this time. So we're going to rearrange it for work is power times time before substituting the values. And then we're going to put in 2 for our power, 3 for our time, which means we've got 6. Oh, hang on. Kilowatts, minutes. They're not the right units. So it can't be 2 times 3 equals 6. We have to convert the kilowatts into watts and the minutes into seconds. So that means it's going to be 2000 times 180 because of these. They've always got to have those units watts and seconds. Which means we have 3600, oh, too many zeros there. I'm going to turn those into kilowatts. That's much better. So 360 kilowatts, or you can do is 360000 if you like in joules. Just be careful how many zeros you write down in the real thing. Right, third example then. So here we've got a car, it's got 50 kilojoules of kinetic energy store, and it's going to brake and come to rest in 2.5 seconds. And we're going to calculate the power of the brakes. Now, in this one, we don't have a force, we don't have a distance, but clearly we need to have some sort of work. So we need to remember this, that work is done when energy changes forms, or if you prefer, changes from one store to another. So here the kinetic energy store has changed. It's gone from 50 kilojoules to rest. And that's what that 0 means there, from rest. So the work done is 50 kilojoules. Now we can get on with our power equation. Substitute in, and we get an answer of 20 kilowatts. Let's have a look at another example. So someone in a bobsleigh team is going to exert 850 newtons over 10 meters, and they're going to do that for 3.5 seconds. And we're going to calculate the power of this team member. Okay, so power is work done over time, so we need to work out the work first. So there's our equation for work. Force 850, distance 10. The work done is 8,500 joules. Power is work done over time. Substitute the work in and the time, and we get a horrible little number there, way too many significant figures. Looking at the question, I'm going to say 2 significant figures is a little bit more useful, so 2.4 kilowatts. Last example then. So a student's going to lift their bag into a locker. The gravitational potential energy store of the bag is going to increase by 350 joules in 0.5 of a second. We're going to work out how powerful the student is. We've got to try and identify what work is being done here. I haven't got an equation for gravitational potential energy, but I'm told that the increase in gravitational potential energy is 350 joules. So remember that work is done when energy changes from one store to another. So gravitational potential energy store is changing here, and it changes by 350 joules. So that's the amount of work done. Now we can go power, work done over time, substitute in, answer of 700 watts. Don't forget to set your work out when you're doing these. So thank you very much for tuning in. Don't forget to subscribe to the channel. I'll see you next time on Spiral Physics Education. Goodbye.